Hi, this video is about dimensional analysis. In AP Chemistry or in any chemistry class, a big part of it is learning how to solve problems. And so dimensional analysis is a very powerful tool to use when you're solving problems in science. All right, so let's get started with a pretty basic way of using this tool, and that is dimensional analysis converting English to metric units. I'm not sure if you can see, but my cat is right here. Okay, Zeus is in, yeah, here we go. Say hello, and then you need to, can you say hello? This is Zeus, this is the boy cat. Okay, now I have to get to work. Okay, so we're gonna convert English to metric units. And what we're going to use is a conversion factor, but it's really what we call an equivalence statement. And what we mean is that it's two things that mean the same thing. So here we go. We are usually given conversion factors. If you have to memorize conversion factors, we'll let you know that. But English to metric ones, you don't have to have memorized. There are 2.54 centimeters in an inch. So that 2.54 always goes with the unit centimeters, and the 1 always goes with an inch. And we can write 2.54 centimeters in 1 inch, or we could write that 1 inch is equal to 2.54 centimeters. What's important is that the 2.54 goes with the centimeters and the 1 goes with the inch. You could have flipped them, and which one you use solving a problem depends on if you're converting from centimeters to inches or inches to centimeters. Notice whatever in the numerator should mean the exact same thing as what's in the denominator. That's what we mean by an equivalence statement. All right, so when we convert from one unit to another, what we're going to do, we're always going to start with the given value. Now, really, this method, the units are even more important than the numbers, so make sure you write down your units. You will use the equivalence statement that will relate your units if there is one. If there's not, you may have to do a little work to get there. Using your units, you're going to make sure you're using the correct form of your equivalence statement, and then you're going to solve. All right, here's our equivalence statement or our conversion factor. A mile is 1.60934 kilometers. Remember Miss Reed? She was running marathons. A marathon is 26.2 miles. How many kilometers will she run? Well, what we do is we always start with what's given, the 26.2 miles, and right now we're just going to concentrate on the units. Okay, here is miles. Now we're going to kind of make this box here. Miles is in the numerator, and in this equivalence statement box, this is the numerator, this is the denominator, the miles is going to go down here. The reason it goes down here is so that it will cancel. So the numerator, denominator, unit cancels. And we want kilometers, and luckily they give us a conversion factor that 1 mile, so the 1 goes with miles, is equal to 1.60934 kilometers. And we are done. We have the unit we want, the unit we didn't want cancels. Now let's pay attention to the numbers. It's 26.2. This number is in the numerator on the top of the box, so we're going to multiply them together. 26.2 times 1.60934, and the answer we get, and this is 3 significant figures, so our answer should be in 3, is 42.1 kilometers. Okay, not so bad. All right, so here we go. We have a car, and it's advertised as having a gas mileage of 15 kilometers per liter. Now, we're going to change this to miles per gallon. And so this has 2 units in it, and we've got to change both. And one of the units is in the numerator, and one is in the denominator. We're going to worry about one at a time. All right, so let's go ahead. And let's start with what was given. And it was 15 kilometers per liter. All right, I'm just going to make a decision. It doesn't matter what order you do this in, but I would like to just get rid of that liters in the denominator. Okay, I don't want liters, I want gallons down there. So I'm going to put liters up here so they cancel, and I'm going to put gallons down here. We'll come back and fill in the numbers later. All right, I got my denominator taken care of. Now in the numerator, I don't want kilometers, I want miles. So kilometers is going to have to go in the denominator so that it will cancel. Oh, that was Zeus again. And miles is going to go in the numerator because that is what we want. Now, our units have canceled. We're left with miles in the numerator, which is what we want, gallons in the denominator. Now let's put in our numbers. How many liters in a gallon? Well, the 3.7854 liters is in a gallon, and then 1 mile is defined as 1.60934 kilometers. All right, what are you going to do in your calculator? You're going to put 15, this is in the numerator, times 3.78541, this is in the denominator, divided by 1.60954, and our answer winds up being 35 miles per gallon. And that sounds like a reasonable answer for gas mileage of a car. Let's see, there were 2 significant figures here that was given, and so 2 in our answer. All right, density. So we have, used density a lot in different science classes, and you were told that density is mass over volume. Remember me, I just love density, mass over volume. And it's a way to identify an unknown substance. It's called an intensive property. It doesn't depend on how much you have. And it does change with temperature because volumes generally change with temperature. All right, but we've never really looked at it as a conversion factor. And so we're going to do the next problem. We'll use density as a conversion factor. But here, let's go ahead and just do a simple density problem and pay attention to sig figs. All right, you have an unreactive metal, you put it in a graduated cylinder, and it's half full of water. So I like to kind of mentally, when I look at data, I like to mentally make a picture, or I can even draw it out. So here I've got like this graduated cylinder, I got some water in it, and then, here comes my unreactive metal, and when I put it in there, what's going to happen to my water level? First of all, it's going to make a nice plopping noise, and the water level is going to go up, and there's your metal sitting in the bottom. Okay, so here's our data. We got the mass of the metal, the volume of the water before we plopped the metal in there, and then whoop, we plopped it in, and our volume went up. Okay, so how should we report the density? Well, density is mass over volume. Oh, thank goodness they just flat out gave us a mass, 19.611 grams, but our volume we're going to have to kind of figure out. The amount of water that this displaced is equal to the volume of our solid, and so our volume went from 14.9, or it went up to 14.9 from 12.4. So our volume, and it's only 2 sig figs, is 2.5 milliliters. So when we calculate this, our calculator is going to give us this 7.84444. It's going to give us lots and lots of digits, but not every one of those numbers is significant. We are dividing by 2.5, so we only have, this is Boots, by the way, just introducing you. This is the female cat. This is Zeus's brother about to step on the computer. Say hello. All right, so we're going to have 2 sig figs in our answer, and the answer should be reported as D, 7.8 grams per milliliter. All right, let's look at density as a conversion factor. All right, 75 mils of benzene, they give you the density, and they'd like to know the mass. So doing our great dimensional analysis, this powerful tool, we are going to take what was given, 75, and that important unit. We don't want milliliters, so we're going to put it down here in the denominator. We would like grams, and our density is our conversion factor. So we got 0.879 grams is in a milliliter. And so we're going to multiply these together, and our answer is to 3 significant digits because that 0 is significant. It's after a decimal. It is 65.9 grams. Okay, so this is just showing you how the density of water changes with temperature. But now, let's throw one more thing at you. A lot of times when you see percentages, you don't really know what to do with them. So let's go ahead, let's read this problem. You got a car battery with sulfuric acid. They would like to know the grams of sulfuric acid in a half a liter of the battery acid. So we're looking for grams, and they give us a density of the solution, but only 38.1% of the solution is sulfuric acid. And so the only thing new that we're adding here is this percentage. So let's go ahead and start with what's given. What's given is the half a liter. All right. Well, the density was given in grams per milliliter, so we've got to change that liters to milliliters. And the liters is going to go down here and milliliters is going to go up here. This is a conversion factor you need to know. There are 1,000 milliliters in a liter, and so we actually have 500 milliliters of our battery acid. All right, and these zeros would be significant because they were after the decimal, so I made them significant here in this answer. All right, so let's start with our 500 milliliters. And we don't want milliliters, we would like grams. Our density is 1.28 grams per milliliter. And the amount of grams that we get here is, oh goodness, I don't have my calculator. Let's see. It's going to be, I'm not sure. Then what we're going to do is we're going to get that answer and we're going to multiply it by however many grams that is. So go ahead and do that. And then you're going to multiply it by this percentage, because of those grams, only 38.1% of them are sulfuric acid. So that answer times 0.381 will give you the grams that are sulfuric acid. And that answer is 244 grams. Okay, now prefixes. Let's just quickly tell you what you need to know. You need to know at least these definitions for prefixes. So for instance, kilo, the definition of a kilo is that a kilo is 1,000 whatevers. Okay, remember these prefixes can go in front of any unit. A centi, let's use meter. Let's put the prefix in front of. A centimeter is 1 times 10 to the negative second meters. Milli is 1 times 10 to the negative third. Micro, and that has this funky mu, is 1 times 10 to the negative sixth. Nano is 1 times 10. Oh, I'm seeing a pattern here. 10 to the negative ninth, and pico is 1 times 10 to the negative 10th. Usually if you have, no, 10 to the negative 12th, excuse me. Usually if you have these pretty much memorized, you're good to go. And then we can do dimensional analysis with unit conversions. So these should be pretty straightforward. Let's go ahead and practice converting 25 milliliters to liters. All right, we don't want milliliters immediately. Denominator, we want liters. A liter is 1,000 milliliters, okay? And so we come up with 0.025 liters. Or we could have done it this way, 25 milliliters, and a milliliter is defined as 1 times 10 to the negative third liters, and you're going to get the same answer, 0.025 liters. All right, now here we're converting from prefix to prefix. And when you have that type of situation, what you need to do is you need to go from milligrams to grams, and then from grams to kilograms. So let's do that. All right, I'm going to work up here. 350, ooh, looks like only 2 sig figs, milligrams. I don't want milligrams, I want to get rid of it, so we're going to go to grams. I don't want grams, I want kilograms. So see how I used my units here? Milligrams cancel, grams cancel, and I have kilograms. All right, a milligram is 1 times 10 to the negative third grams, and a kilogram is 1,000 grams. And when I do all of this, and I can do this without a calculator, this is 3.5 times 10 to the second times 1 times 10 to the negative third. So 2 minus 3 is 3.5 times 10 to the negative 1 divided by 1 times 10 to the negative third. So we're subtracting our exponents. Our answer should be 3.5 times 10 to the negative fourth kilograms. All right, so dimensional analysis, powerful tool. Using your units is key. The numbers are kind of secondary. You just, at the end, just plug them in. So make sure that you understand dimensional analysis, and we're going to have a video that even expands on this. Thanks a lot.